Hello students, today I will discuss the next unit, that is electromagnetic wave. In short we can write EMW. So to know about the electromagnetic wave, we have to discuss here about the scientist Maxwell. Now according to that, an accelerated charge produces a sinusoidal time varying magnetic field, which in turn produces a sinusoidal time varying electric field. These two fields are mutually perpendicular to each other, and these are the source of each other also. So uh, these magnetic field and electric field, they constitute the electromagnetic wave and which propagate in the space in a direction perpendicular to the direction of both the fields. So this is the explanation, and we can write the definition in such a way that the electromagnetic wave consists of sinusoidally time varying electric and magnetic fields acting at right angle to each other as well as right angle to the direction of propagation of wave. So this is the definition. Now in your syllabus, next is what are the properties of electromagnetic wave. So the first property can be written from the definition of the electromagnetic wave, and that is property number 1 is electromagnetic wave propagate in the form of varying electric and magnetic fields such that the two fields are perpendicular to each other. Similarly, point number 2, the electromagnetic waves are produced by the accelerated charges. Point number 3 is the electromagnetic wave do not require any material medium for the propagation. And point number 4 is the electromagnetic wave travels with a velocity that is c is equal to 1 upon square root epsilon naught mu naught. The formula is written at the point number 3 on the blackboard. C is equal to 1 upon square root mu naught epsilon naught. So it gives the value of a speed of light, that is 3 into 10 to the power 8 meter per second. Similarly, next property is the velocity of light. The velocity of light may be the velocity of the electromagnetic wave. Both are the same thing because light is also a electromagnetic wave. So velocity of electromagnetic wave, it can also be written as the ratio of the amplitude of the electric field to the magnetic field. The formula is written on the blackboard at the point number 4. C is equal to E naught upon B naught. E naught is the amplitude of the electric field, B naught is the amplitude of the magnetic field, and the ratio of these two is always equal to C, and C is the speed of light, that is 3 into 10 to the power 8 meter per second. So these are the main properties of the electromagnetic wave. So next point is how can we show that the electromagnetic wave are transverse in nature. So to show that electromagnetic wave transverse in nature, we have to write some explanation by the graphical representations. You can see in the blackboard there is a graphical representation of the electromagnetic wave is drawn. So in that graph, the wave is propagated along the x-axis. The arrow sign is indicated here, and in the downward direction is written as direction of propagation of wave. The vector which are drawn inside the wave parallel to the y-axis up and down, these vectors are known as electric vector. These are the time varying, this shows the time varying electric field. And the another vectors which are parallel to the z-axis, these vectors, these are drawn just you can say parallel to the z axis. So these are the magnetic vector. These two vectors always mutually perpendicular to each other. So in the y-axis, that is, these are the electric field vector, and along the z-axis, these are the magnetic vectors, and these vectors are shown in the electromagnetic wave. So we have to draw the graphical representation of the electromagnetic wave as drawn on the blackboard. And after that, we have to explain that diagram. So from the graph, we can say that the propagation of electromagnetic wave is along the x-axis. The electric field vector E along y-axis, and magnetic field vector B is along z-axis. the propagation of electromagnetic field is in the direction of vector E vector cross B vector, and we can show the equations of the electric field and magnetic field, that is written on the blackboard, that is E equal to E naught sine omega t minus x upon c, equation number 1, and similarly B is equal to B naught sine omega t minus x upon c, that is equation number 2. So these are equations of the electric field that is produced when the wave is propagated along the x-axis. So we can say that the electric field vector and magnetic field vector, these are mutually perpendicular vector, and these are vibrating along the y-axis and z-axis, but the wave is propagated along the x-axis. It means it obey the obey the nature of the transverse wave, because in the transverse wave, when the particles of the medium vibrating perpendicular to the direction of propagation of wave, then such wave is known as transverse wave. So here is the electric vector and the magnetic vector, both are vibrating, both are oscillating along the y-axis and z-axis, and in these two y-axis and z-axis, x-axis is perpendicular to these two axes, so wave is propagated along x-axis, but the electric vector and magnetic vector are vibrating along y-axis and z-axis. So these two vectors are mutually perpendicular to the direction of the x-axis. So we can say that the electromagnetic wave is transverse in nature. So it is the qualitative idea that is in your syllabus. Mathematical idea or the quantitative idea is not included in your syllabus. Okay. So next thing is, what are the electromagnetic spectrum? So first thing is, what is the definition? So electromagnetic spectrum means the orderly distribution of electromagnetic wave in the form of distinct groups having widely differing properties is called electromagnetic waves. So electromagnetic waves mainly consist of gamma rays, X-rays, ultraviolet rays, visible light, infrared rays, microwaves, and the radio waves. So we have to discuss about these waves. What are the origination of such waves? So number one is gamma rays. So gamma rays are originated by the nucleus of the element. So we can say it is a nuclear originated. Number two, X-rays. X-rays are atomic originated. Number three, ultraviolet rays. Ultraviolet rays are produced by the arc of the mercury and the iron. Arc means just like a spark. So arc of the mercury and iron. Next is the visible light. So visible light is emitted due to the atomic excitation. And next is the infrared rays. Infrared rays are produced by the hot bodies. And next point is microwaves. And microwaves are produced by the oscillating electronic circuits. Similarly, the last, radio waves. Radio waves are also produced by the oscillating electronic circuits. So these are the originations. Next thing is, what are the frequencies of such waves? So I am discussing here one by one. So number one, the frequencies of the radio waves, that is the range of the frequency of the radio waves is from 3 into 10 to the power 3 to 3 into 10 to the power 11 Hertz. Similarly, the frequency of the microwave, that is from 3 into 10 to the power 8 to 3 into 10 to the power 11 Hertz. Similarly, for infrared rays, 3 into 10 to the power 11 to 4 into 10 to the power 14 Hertz. Next, for visible light, 4 into 10 to the power 14 to 8 into 10 to the power 14 Hertz. Next is for the ultraviolet rays, that is 8 into 10 to the power 14 to 8 into 10 to the power 16 Hertz. And similarly for the X-rays, that is 1 into 10 to the power 16 to 3 into 10 to the power 9 Hertz. And the last, gamma rays, 3 into 10 to the power 19 to 5 into 10 to the power 20 Hertz. So these are the frequencies of the electromagnetic rays which consist of the electromagnetic spectrum. Similarly, we have to remember about the wavelength of the rays that will be asked in the examination. So number one, I will start from the gamma rays. The wavelength of the gamma rays is from 6 into 10 to the power minus 13 to 10 to the power minus 11 meter. Wavelength of the X-rays 10 to the power minus 11 to 3 into 10 to the power minus 8 meter. Similarly, for ultraviolet rays 4 into 10 to the power minus 9 to 4 into 10 to the power minus 7 meter. And for visible light 4 into 10 to the power minus 7 to 8 into 10 to the power minus 7 meter. And for infrared rays 8 into 10 to the power minus 9 to 3 into 10 to the power minus 3 meter. And for microwave 10 into 10 to the power minus 3 to 1 meter. And for radio waves 10 to the power minus 3 to 10 to the power 5. 10 to the power minus 3 to 10 to the power 5 meter. So these are the wavelength. So these rays can be asked in the examination from the frequency point of view, from the wavelength point of view, or any of them. Maybe suppose some wavelength is given in your paper, maybe some frequencies is given in your paper, and in the paper the question will be there, what types of electromagnetic waves having the frequency that is written in the paper. So such type of questions, or maybe wavelength, such type of questions may be asked in the examination. So this is the introduction of the electromagnetic wave, then electromagnetic spectrum with properties and transverse nature of the electromagnetic wave. It's a completely theoretical chapter, and I am speaking. You can write you can make the notes from the video, and after that in the second video we will discuss about the applications and the properties of the waves by which the electromagnetic spectrum is consist of. Okay, thank you very much.